Hi folks, we're going to take a look at page 408, number 7. We've got two examples of solving exponential equations. Okay, so in both these scenarios, what we're looking for is to try to have all the expressions with powers to have the exact same power. Okay, so here if I look at the simplest power, I've got 4 to the x. So my goal is to write this so that it has a 4 to the x. Okay, and at this point here, hopefully you can see using the third exponent law that I can rewrite that as 4 to the x squared. So minus 4 to the x minus 20 equals 0. And I recognize this as looking like a quadratic equation. Okay, so again, it might help to, instead of working with 4 to the x's, let's let some intermediary variables, say z, be equal to 4 to the x. And so now when I replace z into the equation, I get something much more user-friendly. So here I can easily factor that, luckily. So it's z minus 5, z plus 5, okay, equals 0. And so z is equal, z plus 4, of course. So z is either equal to 5 or z is equal to negative 4. Okay, but it's not z I'm interested in, it's x. So this is where now I place 4 to the x back in. Okay, and so here I can't really make these the same base, so I'm just going to take the logarithm both sides. So x is equal to log base 4 of 5. Or, well, in this case here, there is no or, because 4 to the x can never be equal to negative 4, since 4 to the x is always positive. Now, if you had tried to take the logarithm of both sides, you would have seen that you'd have had log base 4 of negative 4. You should have seen then that that wasn't going to give a solution. Okay, so this is your only answer. Now I believe the answer that's given is in terms of log base 10. No problem, just use the change of base formula. So how do we change this to log base 10? It just becomes log base 10 of the original input, which is 5, over log base 10 of the original base, which is 4. Okay, so let's take a look at B now. Okay, so I'm just going to rewrite it here. So exactly the same idea as before, is I want to try to get the same power in all variable expressions. So my simplest one here is 2 to the x. So let me see if I can write this using 2 to the x. Okay, well, here we again just have to use what we know about exponents. So we know that a negative exponent, the effect of a negative exponent is to give you the reciprocal. Okay, so 2 to the negative x is the same as 1 over 2 to the x. Okay, so I can rewrite this expression in this form. And hopefully now you notice that this looks a lot like a rational expression. So I'm going to do the same thing as I did before. I'm going to say let z equal 2 to the x. And so now I have z plus 12 over z equals 7. And I'm going to solve this the way I solve any rational equation, by multiplying both sides by the lowest common denominator, which is z. So that gives me z squared plus, when I multiply just to make sure we know exactly what I'm doing, multiplying both sides by the lowest common denominator. So here the z's cancel out, so I just have 12, and here I have 7z. Okay, so bring everything to one side. Again, I have a quadratic. Okay, and so this again, we're lucky, factors out quite nicely. So it's z minus 3, z minus 4. Okay, and so here z is equal to 3, or z is equal to 4. But of course we're not interested in z, we're interested in x, so now I'll replace z by 2 to the x. Okay, and again, replace z by 2 to the x, and now I can solve this. Okay, so here, this is going to be x. It's going to be log base 2 of 3. Okay, or here, I don't actually need to take a logarithm, because here I can clearly see that x2 squared is going to be equal to 4. So x equals 2. Okay, so again, just to recap how we solve these problems, okay, is when you see different powers, okay, but that can be written using the same power throughout, okay, that's what you're looking for.